Welcome back, friends, to the third video of Learner Physiology. So in this we're going to talk about distal convoluted tubule and collecting duct. So before you watch, please make sure that you subscribe, you share, comment, and also like. So let's now see what is being reabsorbed. Distal convoluted tubule, it is divided into two sections. It has the early distal convoluted tubule and late distal convoluted tubule. So when you talk of the early distal convoluted tubule, what is being reabsorbed are sodium, chloride, and calcium. The early distal convoluted tubule, it is also impermeable to water, but the reabsorption of calcium, sodium, and chloride, it is also dependent on the sodium potassium pump. The sodium potassium pump, this is the driving force for the reabsorption. Let us just draw the segment of early distal convoluted tubule. So the late distal convoluted tubule, it is composed of sensitive cells known as macula densa. These macula densa are sensitive to sodium concentration in the tubule. The macula densa, they are responsible for bringing the blood pressure up when it is low and to increase the blood pressure based on the concentration of sodium, of which we are going to talk about next video. So this is sodium, chloride, and calcium. So these are reabsorbed with the help of sodium potassium pump, which is the driving force. So the sodium potassium pump, it is located at the basolateral of the early distal convoluted tubule. So we are going to see how it works. So let us just redraw the early segment of the distal convoluted tubule, and this is the blood vessel. So these are the cells which is responsible for the absorption. So these are sodium potassium pump. So sodium potassium pump, it moves 3 sodium ion out of the cell into the bloodstream, and then it pushes 2 potassium ion into the cell, and then the sodium that is in the distal goes into the cell together with chloride using the channel NCC channel. So the sodium that the cell loses, it is its own sodium. Then in order to compensate, it allows the sodium which is in the distal convoluted tubule to be pushed into. So the movement of 3 sodium into the bloodstream, it creates chemical gradient for sodium. Hence, sodium and chloride is pushed into the cell to compensate. Calcium goes into the cell using calcium channel. So the decrease in blood sodium concentration does not affect the decrease of normal intracellular sodium concentration. That's why when there is a decrease in sodium, the cell using sodium potassium is able to use its sodium to pump it into the bloodstream, and then it is being compensated by reabsorbing it from the tubule. Let's talk of what is reabsorbed at late distal convoluted tubule. We have also sodium and potassium is circulated out of the blood into the tubule, and water is reabsorbed in here. So for the late distal, it is permeable to water. So sodium and potassium, it is also dependent on sodium potassium pump. Remember, sodium potassium pump are located at basolateral of the tubule. The reabsorption of sodium of the late distal convoluted tubule, it occurs in the principal cells. So the principal cells are responsible for reabsorbing. So let us just draw the late distal convoluted tubule. So with the principal cells, remember the reabsorption of sodium and circulation of potassium, it is based on the sodium potassium pump. So here is sodium, we have water in the tubule. So what is being pushed outside is 3 sodium, then into 2 potassium, driven by sodium potassium pump. So in order to compensate the lost sodium, using epithelial sodium channel, sodium is pushed into the cell. So let's assume this is the structure of the cell. So this is the cell. Then since 2 potassium is being circulated from the blood into the cell, so the same potassium is circulated into the tubule using potassium channel. Also, water is being absorbed using the aquaporin channels which are inserted. So water is reabsorbed into the bloodstream. So that's it for distal convoluted tubule. So let's talk of collecting duct. The collecting duct has intercalated cells. So the intercalated cells are divided into type A and type B. So type A, it is responsible for acidosis. Then type B, it is responsible for alkalosis. So mainly collecting duct is known for water reabsorption and acid-base balance. So let's say the body is in acidosis state. This means that the pH of the body is less than 7.35, which is acidosis. How does the body respond? This, we know that during acidosis there is increased number of hydrogen ion in the bloodstream. So how does the body respond during acidosis? So this is what we're going to see, how a kidney plays a part, specifically the collecting duct. So using ion channel, hydrogen is circulated from the bloodstream into the tubule. Then the bicarbonate is pushed into the bloodstream, which lowers the pH of the blood to normal. So the bicarbonate, it exchanges with chloride using chloride shift channel. So bicarbonate, it is pushed into the blood, and chloride, it is pushed into the cell, which is the antiport transport. Bicarbonates are bases. This means that they increase the pH of the blood to normal, which is between 7.35 to 7.45. Hydrogen is now pushed into the tubule using hydrogen channel, but the hydrogen can go back to the bloodstream, which can again cause acidosis. In order to prevent this, hydrogen is reacted with ammonia to form ammonium. So ammonium is now excreted through urine. It can also react with phosphates to form dihydrogen phosphate. So this is how hydrogen ion is being prevented from going back. So hydrogen ions are excreted out of the body through urine in form of ammonium and also dihydrogen phosphate. So in the next video we are going to talk about the RAS system. We're going to see how water and sodium is regulated in the body. So thank you so much for watching my video. Please don't forget to subscribe and also to share and comment. Thank you. See you in the next video.